Okay, so how actually the probability one thing I would like to give you some maybe a more fundamental things. Okay, why the probability distribution function is related to histogram. Okay, if you remember, okay, that is one things that I would like to give some examples there. Let's go to this example. I think it's better to go to the slide there. Yep, this one. Okay, so this is given this is the input of the image. Okay, this is and then okay, because this one is there's the information, the question the question is not given, so a lot of information is lost there, so you don't get the information there. Okay, assume this is image. Okay, it is 3 bits image, or in other word, the intensity level resolution. Okay, intensity level resolution is equal to 3 bits per pixels. So then from this one, from this image, please produce the histogram. Of course the histogram have been produced here, so this is the answer. So that the question is, from the image, okay, find the histogram of the image. Of course, again, okay, you need to utilize the information or the keyword from the question there, since we know that this one is 3 bit. Okay, previously I talked more about 8 bit per pixels, which is a default intensity level resolution. But again, like I said, in hand calculation question, it the intensity level resolution might be less than that, in order for you, for easy for you to you know to calculate, or it's more possible to make it hand calculation, and you can done it within exam time or test time. If I ask you to compute the 8 bit per pixel, then of course the histogram, you can see the histogram there. Okay, it's very very wide there. Okay, if you talk about hand calculation, it might be impossible for you to do. That's why if you want to prove it, you can do the programming, and then you can simulate it in MATLAB and so on. So for the practical image, but for hand calculation, that's why we have a very small intensity level resolutions there, 3 bit per pixels. Then can you find, or can you build the histogram of the image? So this is how you build the histogram. Okay, so again, because this one is a 3 bit per pixel, then the L there is equal to 8, or you have number from 0 to 7. Okay, because I always you can see that 3 bit I just go to 8, because that is because that is based on experience, because the more time you dealing with this thing, then 3 bit is 8. But if you don't remember, if you remember that there's a formula there, right? Okay, 3 to the 2 to the power of something, 2 to the power of 3 minus 1. Okay, this is your L minus 1. Okay, that you learn in electronic digit. Okay, if you're not sure that 3 bit how many, then you must use the formula. Okay, but this one I assume that you know the formula, so just 3 bit, so automatically you can remember that 3 bit should be 0 0 0 to 1 1 1. So that's why from 0 to 7, so the total levels there should be 8. So that's why I directly write something like this, 8. And then you can have from 0 to 7, this is black and this is white. Okay, if you want to plot the histogram, this is your R. So this one is from 0 to L minus 1, which is your 7. And then this is the frequency, or the numbers of pixels. Okay, or the numbers of pixels with intensity equal to R. Okay, this one. So you can see that how many pixels here belong to 0. You have 1, 2, 3. So that's why you put there 3. So then why you generate there 3. And then 1 over here. So how many? 1, 2, 3, 4, 5. So you have 5. and then you have 2 there, 1 2 3 4, so you have 4. So that's how you generate the histogram of the image, okay, by having a manual calculation. So this is the histogram. Okay, this is basically the histogram. So if you talk about PDF, why PDF is related to the histogram? Okay, because if you talk about the PDF, you can have something like this as well. Okay, this is your R. Again the same, this is your R, or in this I think in the equation there they using they use the notation as yep, R. Okay, if you talk R here, okay, the same there, using R. Okay, because I want to plot because the okay, because the color is can I change the color? Okay, good. Okay, okay, how many pixels over here? If you talk about this one, okay, this you can count the pixel there, 1 2 3 4 5. Okay, because I want to know the sampling resolution, 1 2 3 4 5. This one is 4, so 5 times 2. Okay, 5 times 2, 5 times 4, which is 20 pixels. So that is the sampling resolution. Or you have 20 matrix element, you have 20 element inside the matrix. Okay, so another way you can know whether it's a 20 or not, you can count over here. Okay, this one is 3, this one is 5, okay, this one is 4, then this one is 2, okay, and then it's 2, this one 2, and this one is 2. So if you total up all this number, you also get 20. Okay, 3 plus 5 plus 4 plus 2 plus 2 plus 2 and plus 2, you get 20 as well. So if you want to plot the PDF, let's say this is your PDF, or okay, you can do something like this as well. Okay, PR or PK doesn't matter, because the equation there using a PK there. Okay, the equation there using a PK there, because K as well is refer to the intensity. Okay, the intensity value. Okay, so that's why here I'm using R there. Okay, so the probability distribution function, okay, this one is when the R equal to 0, the probability distribution function is 3 divided by 20. And then if you have here 1, okay, actually is 5 divided by 20. And this one 2, then you have 4 divided by 20. Okay, then you have another one 3, this one should be 2 by 20, 4 as well 2 by 20, and then you have 5 also 12 divided by 20, and then you have 6 over here, 2 divided by 20, and you have 7s there, 0 divided by 20. Okay, so so this one is according to this formula. Okay, because numbers of pixel where the intensity value is equal to 0, okay, the first one, this one, okay, equal to 3, so you get here 3, and then you divide the total number of pixels. Okay, same goes to this equation there. Okay, you divide by 20, divide by 20, and 20 is the n totals there. Okay, actually the shape of histogram and the shape of probability distribution function, this is called as a probability distribution function, or PDF. The shape of probability distribution function and the shape of histogram is almost similar. Okay, the difference is just the y value there, the y-axis value there. This one is the frequency, but this one is a probability. So that's why you you get here 0 point something, this one 0 point something. But if you total up this one, each and every value over here, you will get 1. Okay, because everything is divided by 20, but the total here, the total numbers here is 20. So in other words, if you plus all together this number, at the end you get 1. So why histogram is related to probability distribution function is because if you learn in secondary class, in secondary school, okay, if you talk about the probabilities, okay, the probabilities in your mathematics, what is the definition of probability? Probability is how many time that things occur in one event. Okay, how many time, what are the probability that that event is happen at that time. So same goes here. What are the probability that this image can produce 0, for example? What is the probability? Of course, you must calculate the number of that event happen, which is 3, 1, 2, 3. Then you must divide by the total number of event. So what is the total number of event? Is your 20 numbers here, or the 20 matrix element here, or the sampling resolution, which is 20. So what are the probability that that pixel is equal to 1? Of course, it's equal to, the probability is 5 minus 20, which is how many percent there? You must get that is the probability. So same goes to the other numbers there. What is the probability that the pixel equal to 2? Okay, to get the probability, then you must calculate or count how many 2 there, 1, 2, 3, 4. Then you must divide by the total number of event, where the total number of event is 20. So in other words, that is why in order for you to generate probability distribution function, you are required to get the histogram of the image, because by having the histogram of the image, you can obtain the frequency, and from the frequency you can generate the probability distribution function. Or in other words, I also call probability distribution function as the normalized histogram. Actually, this is look like a normalized histogram. Why I call it normalized histogram? Because from the direct number event there, or the frequency there, by having the probability distribution function, everything there is 0 point something. If you total up, is equal to 1. So it's look like a normalized histogram. So in other words, you can also call probability distribution function as a normalized histogram. Okay, so in this histogram equalization, we need that PDF, because once you have the PDF, then you can execute this formula, okay, by having a summation of each and every probability distribution function over here. Then you can get your cumulative distribution function, where this one is your transformation function. Okay, so this is actually okay, back to our objective. Why we need the cumulative distribution function as a transformation function? Because that is the way you can, yeah, this is the purpose of this one. Okay, because the cumulative distribution function of each image will actually can map, okay, the input image to the output image, where the output image later can have this kind of very equalized histogram, okay, which is we are going towards producing the ideal high contrast image. Okay, doesn't matter which condition, by having a transformation function which is cumulative distribution function, actually you will map the input into output image, where the output image is if you generate the histogram is look like this one. Okay, it's not 100% like this one, but we can have something more close like this one, where which actually we are going towards getting close to the ideal high contrast image. Okay, so that is the explanation. Okay, don't worry about that, because I will like to explain everything, so then you know how actually where this equation come from. So now you know the process.